Hello Geometry World, this is a video of example 4 for Geometry Topic 2, Lesson 1. Using parallel lines to prove an angle relationship. They want us to prove the angle relationship that if we have given that segment AC is parallel to segment DF and segment BE is perpendicular to segment DF and the angle AEB, this one in here, is congruent to angle CEB. If all those things are true, we need to prove that angle BAE, which is up here, BAE, is congruent to BCE. Okay? Here we go. We're going to, of course, start with a given statement. They didn't list all three of them, but you could list all three of them because they are all given. They saved this one for later, but they want to focus on these two because if those two lines are parallel and segment BE is perpendicular to DF, we can start saying things like that angle BED and BEF are right angles. That's the definition of perpendicular lines. And if they're right angles, we can say they each measure 90 degrees. Okay. We can also say if BED measures 90 degrees, then the measure of angle AED plus the measure of angle AEB equals 90, because the whole thing's 90. And then from the angle addition postulate, this angle plus this angle equals the whole thing. Then they bring in the given that this angle in here, AEB, is congruent to this angle in here, CEB. And if you know these two angles are congruent, and you know those two add up to 90, and those two add up to 90, and you know these two are congruent, we can get to the next part. The measure of it, AED, must be congruent to CEF, congruent complements theorem. Remember, if two angles like AED and CEF are congruent to the same angle or are congruent to congruent angles, or I shouldn't say congruent, if they're complementary to those, then they must be congruent to each other, which we kind of made sense. If these two add up to 90 and these two add up to 90, we know these two are the same. These two must be the same. Moving on, now that we know those two are the same, again, we were trying to prove in the end that this angle up here is congruent to this angle up here. Now that we have these two angles are the same, we can say angle AE, I'll do it the same order they did it. They said BAE. So this angle up here is congruent to this angle here, and angle BCE is congruent to angle CEF. That's from the alternate interior angles theorem. And now that we know that, we can say that BAE is congruent to BCE with the transitive property. Kind of a long way about it, but we did use the alternate interior angles theorem, we use a congruent complements theorem, and some other things that we've used in the past. Now for you, one for you to try on your own. In the text, this has 8 steps to it. If you're ready, go ahead and click pause and then try to do as many parts as you can. I'll give some hints and maybe you can click pause anytime. Given AB is parallel to CD, so that's this top line and bottom line are parallel. Just from that, they want us to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 adds up to 180. Now you might say, well, I know the interior angles in a triangle add up to 180. Maybe you already have that knowledge. That's not what we're going for. That'd be great. We could use that, but they want us to go about it using what we've recently learned in this unit, alternate interior angles or corresponding angles or whatnot. So I'll start off with the given AB parallel to CD, and that's given. And now I'll just go right to their solution. Okay. The next thing they stated, oh, I should have went over this earlier. I can go over it now. How can you find out these angles add up to 180 using what you know from alternate interior and same side interior and corresponding? So you kind of picture what we already know. Okay, they start off with measure of angle 1 plus the measure of angle ACD. 1 and ACD, since they're same side, they don't have a number here, but since they have a same side interior, they add up to 180. So 1 and 3, 4 add up to 180. Okay. So you can see that already equals 180. We need to prove that 1, 2, and 3 add up to 180. We already have 1, 3 plus 4 is 180. There's a hint. You can see what we need to substitute at some point. Next, they have the measure of angle ACD is equal to the measure of angle 3 plus measure of angle 4. That's the angle addition postulate. That's kind of what I was insinuating there, that we can break that up into 3 and 4. So now we could say 1 plus 3 plus 4 adds up to 180. That's substitution. All we need to do now, if you look at the difference between 1, 2, and 3, 1, 3, and 4, is we just need to make 4, replace 4 with 2. And there's a relationship between 4 and 2, right? Angle 4 is congruent to angle 2 is congruent to angle 4 from the alternate interior angles theorem. Notice these are measurements. You can have measurements equal. You have angles congruent. So we need to next state that the measures are the same. Whoops, let's say, scroll this up here. The measures of those two are the same, definition of congruence. Now that we know the measures are the same, we know we can just replace the 4 and the 2 into that equation up here. They substituted it in. Now we have the measure of this plus the measure of that plus the measure of that is 180. And I thought that's what we were trying to prove. 1, 2, 3, 180. 1, 2, 3. Oh, they just switched the order using the commutative property. All right. Hopefully you don't have to do that many proofs in the homework. Let's see what problems you should be able to do. Numbers 11, 21, and 25. That's it for this video. Thanks for watching.